Hey guys, welcome. This is our compound probability. You could probably actually do a lot of this on your own, but I'm going to walk you through it. So here we go. The first side, the side on the other side, you can kind of read through some examples, but I just wanted to get some practice with us in, and let's get going. Describe the events by writing I for independent, D for dependent. We talked about these already, so hopefully going through these will help us out. Anne draws a colored toothpick from a jar without replacing it. She draws a second toothpick. Because she doesn't replace it, that means the amount of toothpicks has changed, so this is a dependent event. John rolls a 6 on a number cube, then flips a coin. That comes up heads. They have no relationship to each other, independent. Susie draws a card from a deck of cards, replaces it, draws again. Because she replaced it, it remains independent. Seth draws a colored tile from a bag, replaces it, draws a second tile from the bag, replaces it, and then draws a third tile. Again, every time we're replacing it, we remain independent. You draw a red marble from a bag, then another red marble without replacing the first, dependent. The probabilities change. Okay? Using the two spinners, find the probability, the compound probability of each. So first of all, the probability of A, that's going to be 1 out of 4. And the probability of getting a 2 on this is going to be 2 out of 6. So 2 out of 6. Multiply those together. We're going to zoom in here real quick. Okay, so 1 out of 4 and 2 out of 6. We can multiply these two guys together, and we're going to get 2 over 24, which becomes 1/12. Probability of getting D, 1 out of 4. And a 1 is going to be 3 out of 6, or 1/2. So we get 1/8. Probability of getting a B or a 3, there's only one 3 and there's one B, so 1 out of 4 times 1 out of 6, so that's 1 out of 24. Probability of A and not 2, so probability of A is 1 out of 4. Probability of not 2 would be 4 out of 6, so we end up with 1/6. Okay. All right, a box contains 3 marbles that are red, 6 blue, and 1 white. The marbles are selected at random one at a time. They're not replaced. Because they're not replaced, we're going to have to do dependent to find the compound probability. First of all, if you add them all up together, we have 10 marbles to start with. So blue is going to be 6 out of 10 times the red, which is going to be 3 out of 9, since we didn't replace it. So we're going to get 18 over 90, and that reduces to 1/5. I'm going to zoom in even more here. I think that should help. Okay, blue and blue, that would be 6 out of 10, and then 5, because we have 1 less blue, and we have 1 less marble, so that's going to be 6 times 5 is 30 out of 90, and that will give us 1/3. Red, white, and blue, so we have 3 out of 10 times 1 out of 9 times 6 out of 8. Okay, so we got to multiply those together. 3 times 1 times 6 is going to be 18 divided by 10 times 9 times 8, and we get 1 out of 40. Red, red, and red. So that's going to be 3 out of 10, 2 out of 9, and 1 out of 8. Okay, so we get 6 on the top, divided by the 10, the 9, and the 8. Whoops, I think I did that wrong. 6 divided by 10 times 9 times 8. There we go, 1 out of 120. White, red, and white. This is going to be 1 out of 10, and then we're going to get 3 out of 9, and then 0 out of 8. Since we have 0, it's impossible. We could just actually, oops, I'm sorry, I was off the page that whole time. Sorry. White is 1 out of 10, 3 out of 9. We have 3 red, we took 1 away. There's no more white left, so it's 0 out of 8, so that leaves us with 0. Okay. All right. Suppose two tiles are drawn from the collection at the right. The first tile is replaced before the second is drawn. Find each compound probability. I want you to go ahead and actually try these ones on your own. We're going to do 15 through 20 in class. So why don't you guys try those guys, and we'll finish this last part off. All right, the spinner to the right for the next two problems. You spin the spinner twice, what's the probability of spinning orange and then brown? This is totally independent. The spinner does not remember, so we're going to do a total of 6 options. We're going to do 2 out of 6, and then the probability of spinning brown would be 3 out of 6. And that's going to give us 1/6. You spin the spinner twice, the probability of spinning brown both times. That's going to be 3 out of 6 times 3 out of 6. That should be 1/4. Kevin has 6 nickels, 4 dimes. If you take one coin out and then a second coin without replacing the first coin, we're going to get the same situation we got before, so I'm going to have you guys actually try that one as well. Okay? We'll review the ones that we put in parentheses later. So we're going to do 23, and this grouping we'll check in class. All right, guys. Peace out.